Swayam Prabha. Digital India. Educated India.
This maritime engineering, as you see, is a very special program which has got multidisciplinary input from mechanical, civil, structural, aerospace, naval architecture, chemical engineering, electrical, electronics, applied mechanics. It's a multidisciplinary program. You will find this program is completely different, dedicated to industrial training and thorough capacity building on the new trade of maritime sector. It's a grooming economy which will give you a lot of job opportunities and research frontiers as far as India is growing. And the Blue Corridor effect, which is planned by Government of India, is one of the important mission which requires maritime engineering growth to happen in the country. So this program caters to expected that capacity building in this program.
Friends, this is part of a material science engineering laboratory which becomes one of the teaching aid for the maritime engineering program. So when you talk about materials innovation in maritime industry, though concrete and steel have been conventional candidates of choice for engineers, for example, we have titanium vessels, high-speed craft boats made of fiberglass. These are all advanced materials which actually do not come across conventional standard design code of practices. We conduct box furnace test, tube furnace test, vacuum arc melting, induction melting, vacuum induction melting, vacuum sealing unit, which are all present in this laboratory is a small segment of material science laboratory. Friends, a typical furnace where the operating temperature for testing specimen can go as high as 12 degrees Celsius. Generally at room temperatures and ambient condition, the mechanical properties will not alter much. As you see in the course lectures, you will notice that strength of the material get degraded when the temperature rises beyond 600. Therefore, when you talk about fire resistant design, you must also choose an alloying element such a manner that the strength doesn't degrade beyond 600 degrees Celsius at all. Welcome to the ambience of IIT Gandhinagar Lecture Theatre. This is one of the interesting classrooms where the maritime engineering classes will be conducted. We have got state-of-the-art projection facility and good audio-visual recording systems. Once the lecture is over, you see the system here. We can generate the PDF files of the lecture directly and you can email the PDF files directly to your email IDs. So it's a state-of-the-art facility we have in IIT Gandhinagar where the lectures are lifetime recorded and shared with the students immediately. This is the IIT Gandhinagar library. This has got all collections of books which are referred as the standard textbooks and references for the course and the program. It also has lot of online editions of design code of practices and reference materials and e-collections of various video lectures of international courses and programs related to maritime engineering. We will be taking you around to the advanced material manufacturing units. So you will have state-of-the-art facilities available at IIT Gandhinagar. So welcome to the program to join MTech and PhD at IIT Gandhinagar Maritime Engineering. So please try to enjoy and take the advantage of this to the maximum. Welcome to the program and welcome to IIT Gandhinagar. Friends, welcome to the 11th lecture on the SwayamPrabha course titled Maritime Structures, Types, Construction, Pre-Service Analysis and Design, offered by Department of Maritime Engineering at IIT Gandhinagar. This is lecture 11 in the series of this lecture. In this lecture, we are going to talk more about floating platforms. We will take an example application of a floating platform, which is one of the interesting applications where repair and rescue operations can be carried out offshore. So, when you have encountered a trouble in case of emergency repair etc. on offshore platforms, you need a floating platform which helps to attend to the repair of this order in offshore. So, obviously at that point of time one will not be able to generally hire a vessel or a ship etc. Therefore, in such cases people generally hire or people generally commission a large floating platform to the side periphery of the main platform for attending repairs and rescue operations near the boat landing area, near the offloading, onloading areas etc. just to facilitate mini cargo movement and personal movement from the platform on and off during the shift changeovers. So, floating platforms have been interesting applications in various fields of applications such as oil and gas exploration, regasification platforms, etc. Now, in this lecture, we are going to see an application example of a repair and rescue operation platform, which is not a permanent platform, it is a temporary platform, but however, it operates on the same style and configuration of a floating platform. Credits to Pauline General Industries Private Limited, Chennai, who has accepted and shared the manufacturing and other details of this polyfloat product, which is very common and very encouragingly used as floating platforms for repair and rescue operations. Friends, polyfloat is one of the product which is actually assembled in groups to create a temporary floating platform. Polyfloat, as the name suggests, is from polyurethane material. It acts as a float. It is one of the most successful temporary floating platform which is generally constructed for repair and emergency rescue operations offshore. So, the unit or the modular segment of this platform looks like a square section of size about 700 mm by 700 mm and the thickness about 400 mm. Okay, it is a unit of a cubic unit of thickness 400 and 700 by 700. Let me write here. So, 700 by 700, thickness is about 400 mm and each unit weighs about 12 kg. Polyfloats actually are manufactured using HDPE, high density polyethylene HDPE material, and size of each modular member is what we see here. We investigated some preliminary studies on this particular member and the platform on the wave basin commissioned experiment studies at IIT Madras to conform to its strength and durability requirements for maritime applications. So, I will be glad to share some of the details of those tests conducted to arrive at certain characteristics structurally required for a temporary floating platform offshore, which I will now discuss in detail. Friends, before we look into the engineering properties assessment of this polyfloat member, let us see what are the possible applications you can use this temporary platform. One can use polyfloat assembly to mobilize equipments for repair and maintenance of construction site in the sea, offshore or even on the riverside, to create a temporary work platform or work base for attending emergency repairs on ship hulls, offshore structures, which are not quite common, but occasionally if they are demanded, then we may require this kind of assembly to be provided for facilitating the repair works on emergency basis. Polyfloat assemblies also help to create work platforms for regular maintenance, because I will show you in the later slides that substructural systems of offshore structures need to be examined at intermittent intervals for its performance and qualitative functional requirements in terms of material grade degradation, corrosion assessment, strength assessment, etc. biofouling characteristics. Therefore, we always need a temporary platform even for regular maintenance of offshore structures, especially cleaning, painting, etc. Polyfloat assemblies are also useful to create inspection platforms for NDT, non-destructive tests conducted on substructural systems of offshore platforms to ascertain its current strength under the presence of lateral loads. So, they are helpful to create such inspection platforms which are generally useful for carrying out non-destructive tests on ship hulls and offshore structures. Sometimes they are also useful to create breakwaters using a combination of combined multi-layer float assembly. We have already seen in the last lecture the use of breakwaters in its application to dissipate wave energy when the wave approaches the coast. So, these multiple level layer assembly of polyfloats can also act as a partial wave breakers or breakwaters. They are also sometimes useful to install solar panel above them in open sea states, so that it can be also used for energy harvesting. So, friends, there are certain tests which need to be carried out before we certify this kind of products or this kind of platform assembly for temporary construction. One is that ASTM D169308, which is standard test and measures for steel cracking of ethylene plastics. So, this is one specific standard which also assesses the durability and strength requirements of such products. The other one is ASTM D1998-04, standard specification for polyethylene upright storage tanks, essentially for liquid storage or even sometimes acid or any alkaline storage chemical can also be done here. So, what are the different ways by which we prescribe or we recommend this product or this particular application for offshore? We have to look into the axial tensile and axial compression test results, its characteristic in bending and shear on a modular float. We also need to look into the impact test which will be carried out on this particular float under calm sea state and operational sea state. We will also have to check the wave impact tests on series of modules of HPTE floats connected to each other using something called polylock system. Polylock system I will show you later. It is an assembly or is an arrangement used to connect successive floats, maybe horizontal or vertical. We also have to ascertain the in-plane bending test for the floats and pull-out test for the key and the connectors, and of course, apparently one is interested to see what is the water absorption test for the floats. As an engineer, one will be also interested to look at the load bearing capacity of each float up to which the level of the neck and for full submergence, which can be then applied to offshore for temporary base. Let us go one by one and try to explain and present the results for discussion. Let us see what are the salient features of a polyfloat. A typical polyfloat, which I am enlarging and showing on the screen, weighs about 12.38 kg. It has got corrugated, hardened HDPE, which is very thick, which can sustain the impact loads on all directions. The polyfloats will be connected to another float using these connectors, which are called as lugs. So, between the lugs we provide the connectors and then that will unlock them, so that the assemblage units of polyfloat will get integrated to become a single piece. So, they weigh about 12 kg. Each float contains protruding legs, what you see here, we call them as lugs, okay, at each corner, which help them to connect to the adjacent units using polylock system. Floats are then sealed with a cap on the top side. So, this is a reverse one, there is another cap on the top. So, floats are actually sealed with a cap on the top side. They are filled with tiny balls of polystyrene as filler material. So, it is not hollow inside, it is filled with some filler material which is polystyrene. Polylink or the connector requires a close evaluation because it may fail in the connections or in the joints. So, one are now looking at what are the possible failures of this polylink when the multiple assembly of these floats are subjected to wave action At the same time, the gravity loads are supposed to act on the top of this assembly. Let us look into the detail of these tests being conducted before we end up in analyzing the engineering properties of the polyfloat for offshore applications. We are interested in looking at the ultimate load capacity, then ultimate tensile strength and the failure mode of these. Look at the figure here. So, when a lug or when the leg of the polyfloat is being pulled by an external force, then at a specific load history this lug fails. So, one can see the history. So, one can say that about let us say 180 seconds from the start of the pull continuously in the same rate of loading, the axial tensile test pull of the lug is about 10 kilonewton. So, here the units are in kg, is 1000 kg. So, we can say 10 kilonewton is the ultimate load capacity in axial tension of the lug, this one. Then one can also work out the ultimate tensile stress in axial tension, which amounts to about 26 Newton per mm square. One is interested to look at the failure mode of this lug. Look at this figure here. The failure mode of this lug essentially is by tearing of the lugs near the connector. So, we can also look at this figure in elongation. When the two lugs are connected together and two pieces are pulled apart, this poly link keep on extending and then it fails at the connections, fails here, and that axial pull is about 10 kilonewton. The connectors are also assessed for the shear capacity, and the ultimate shear capacity is found out to be about 8 kilonewtons. So, it is very clear from the test by physical observation that neither the float joints nor the connectors failed due to shear in the whole test. Connectors slip off slowly, one can see here. Connectors do not fail by shear, but they slip off very slowly from the joint. Initially, when the legs are connected together, this lug is straight, this connector will be straight. Then when I pull this and this apart, they get extended and become like this, as you see here. So, still they do not exit out from the joint, they get elongated and they have a progressive collapse. Neither the float joints nor connectors fail under shear. Connectors slowly slip off the legs. While slipping off, the float connectors resist the applied load due to its end locking. The end locking phenomena is happening here. It is happening here. So, because of the end locking provided by the lugs at the ends of terminals of the poly link, so these end connectors help resist shear when the poly floats are pulled apart in shear. So, they resist the applied load due to the end locking procedure with plastic threads. We call these threads as poly locks or poly links. So, if you look at the axial tension capacity and shear capacity of the lug or the connector, so one can say the shear capacity of the connector is pretty high. The shear capacity is about 12 kilonewtons, whereas the axial tension capacity is about 3 kilonewtons. So, one can also look at the pulling of the lugs and see the axial tension of the connector So, it is also assessed that what will be the shear capacity of the lug, and it has been seen the lugs will not fail in shear because the shear capacity of the lug is pretty high compared to the axial tensile capacity of the connector. So, the shear failure does not dominate in this kind of polyfloat assembly. Having said this, let us see how individually each polyfloat looks like. Individual float can be easily carried by a single person. It is about 12 kg, and these are the lugs what you see, which are useful to connect them to adjacent float, and once they are carried out to the side, they can be easily assembled by providing these connectors, and one can make a very large horizontal and lateral spread area of this platform to cause or to create temporary base for attending any repair or any onload offload items for small cargo. A single person can sit and fix the central connecting pivotal point to join the floats. You can see this point joins all the 4 floats. So, this point joins all the 4 floats, and so on. This point joins all the 4 floats, and so on. So, these connectors are not subjected to shear failure because the shear resisting capacity of these connectors are relatively high. It is about 12 kilonewton, whereas axial pull of the lug is only about 3 kilonewton. So, no connection failure, but a component failure of lugs can happen. So, a large float connected laterally and vertically, okay, layered by layer, can be easily moved, floated to the side. One can clearly see the convenience of walking over this itself. Okay. An enlarged view of this connector actually looks like this. This is the connector. These are the 4 floats, floats 1, 2, 3 and 4. So, they are laterally now connected to assemble to form a platform. So, one can see that the platform is formed here and it can be now ready to be interconnected and used for assembly. So, once it is assembled, the platform looks like this. It also comes in different colors to create a pathway. Then you can also have lugs at these points to create a handrail, and you can also have chains to create a complete pathway. Let us say to create a complete pathway. Let us draw it in different color. So, let us put the handrails here, and you can also connect them. Similarly, put handrails here, you can also connect them. So, one can create a temporary working base like this offshore or along the riverside bank. So, temporary operations in terms of repair, maintenance, etc., can be carried out once the assembly is done. So, one of the major use of the polyfloat assembly is to enable repair and rescue operations offshore. So, once it is assembled, it looks like this. It is then assembled on the banks, then it can be simply towed. You can see here, this assembly is simply towed to the sea. So, installation, fabrication, decommissioning, commissioning, assembling modules to create a platform is very fast. Please note friends, this platform at this moment does not require any anchor. It is a positive buoyant floating system, no anchor is required, it will float on its own. So, for example, this system is now remaining afloat on its own. Okay. So, I will now share a video with you before we understand the applications of this in detail. So, the water absorption of floats is well within the industrial standards. Connectors were found to be very safe in axial tension. They allow extensive post elastic deformation before failure, giving sufficient warning. So, failure of the connection is not sudden, that is a great advantage we have. Okay. It gives enough warning. The failure mode of the lugs is predominantly by tearing of lugs near the holes. Okay, the lugs tear, I already showed you that, see here, the lugs tear before they fail. the lux tear, okay, before they fail. So, this is what we are saying, that the lux stay fear before they fail, and there is no shear failure happening. Failure modes of the lux is by tearing of legs near the holes connected. The ultimate load capacity of this is relatively high. So, neither the float joints nor the connectors fail by shear. Connectors slowly slip off the legs and causes failure. So, one can see before it slips off, it has undergoing a large deformation which enabling plastic failure. Shear resistance is offered by the poly locks. This is seen as a structural advantage as the position of lux is rearranged according to the loading condition. Double layered floats, in sense, if I have floats one over the other, for example, I have an assembly like this. I have one more assembly which can be exactly located above this. So, we can create, and there are legs at this and this, similarly this and this. So, these lugs are plugged with what we call as poly lock connectors, okay, plugged with poly lock connectors. These are the connectors. So, we have already seen that these connectors do not fail under shear. Okay. And look at the close view of this, the lug, while initially the lug is elliptical and the connector is provided here, when the legs are pulled, axially, you will see that the legs are getting teared off. The legs get teared off. So, no shear failure, only legs get teared off. So, no shear failure, only legs get teared off. In multi-layer floats, the multi-layer floats remain stable and maintains desirable flotation characteristics. For a system to float, the system should be positive buoyant, which is of course available in this case. No failure of connectors are noticed even under excessive axial tension, only they slowly rip off from the connection and fail. Dot drop impact test was also conducted to check the adequacy of the molding material. You know, already the molds have been filled, as we said in the beginning, the molds have been filled with the filler material. So, one needs to assess the quality of the filler material, and therefore, dot impact test was conducted to check the quality of the filler material, because the filler material what we generally use or used in this is polystyrene balls completely filled up. So, they are massless. So, the weight is not increased, but the void space is completely compacted. Therefore, we use this kind of material for filling these polyfloats. So, this material filler was also assessed for its behavior using drop impact test, and it confirmed adequacy of the molding material homogeneity. Molding condition of polyfloats are completely declared to be satisfactory. Therefore, it becomes a useful application for temporary offshore base used for repair and rehabilitations. Before we show you the video, let us try to write down the summary of what we learned in this lecture. Friends, in this lecture, we understood that a temporary base is required to attend minor repairs, to carry out inspection on the platform, which are all happening offshore. So, polyfloats in single as well as multi-layered are examined for their structural safety and performance guarantee to be used offshore as a floating platform for temporary applications. Okay, let us quickly see the video to understand how, and we also saw that in the whole assembly of testing reported, floats do not fail, only connections fail, and they do not fail in shear. They fail in axial tension. In fact, the connectors slowly rip off and gives sufficient warning before failure. So, what we want to say here is the failure is not sudden. Okay, that is an advantage. If you have a ductile mode of failure, it is better because it gives enough warning and one can retrofit it quickly before it completely fails. So, we will show you a video now how these polyfloats are assembled. Please pay attention to this video. So, one can see an assembly easily laid, connected and towed to the site in the water body, and you can tow it anywhere you want a location. It does not require any anchorage system at all. It self supports on its own and it can be also constructed in layers. Now, what you see here is a two layered, okay, double layered platform which is created as a pathway for loading, unloading mini cargo on a tug vessel or a boat. Let us see one more video where this is being assembled. See, the polyfloats are interconnected using lugs. One can see the lugs here, one can see the lugs, these are connected, they are towed to the site, carried by people, now it is afloat. It is a new deployment, this can be used as a temporary base for repair. So, you can very well see it is a temporary base being created to attend to a repair of a vessel. You can see here the vessel and it is now moved closer to that. Now it can, and people can walk on this and people can sit and work on this, they can use small machinery, not heavy machinery, but they can use small machineries which can be now useful for inspection, temporary repair of these kind of platforms. So, friends, we have learned the use of temporary offshore platforms floating in nature for various applications like what we see here. So, they can be useful for mobilizing equipment for repair, for creating temporary platform to attend emergency repairs, to create a work base for carrying out regular maintenance works such as cleaning, painting on the platforms or on the hull forms of the vessel, to create inspection platforms for conducting non-destructive tests to compute the strength assessment of ship hulls and offshore structures, can also act as a temporary breakwater to dissipate wave energy along the coastline for immediate protections, one can use multi-layered float assemblies for this. In common, people start using installation of solar panels on open sea, and you need a base to install the solar panels. So, poly floats can act also as a base for installing solar panels in open sea. So, friends, in this lecture we learned use of temporary applications like poly float systems for carrying out repair and emergency services offshore on platforms and hull forms. We have also seen how these platforms are laid, interconnected, and we have also noticed what are the different kinds of tests being carried out on this platform and what are the structural properties of elements of this platform like modular units, so that we ensure that the floats do not fail and the connections fail, but they do not fail in shear, but they fail in axial tension only by slowly ripping off from the connector, sufficiently giving enough warning. So, friends, such kind of arrangements will be very useful for carrying out inspection and repair in coastal side, offshore structures, ship hull forms, shipyards, etc. So, polyfloat is one such assembly which can be conveniently used, and these test results have been certified and conducted at IIT Madras, and further polyfloat and poly industries are also helpful in sharing this kind of technical information for educational purpose through this lecture. While I am thanking you Polyfloat for sharing this information, I also thank the viewers for their patient hearing. Thank you. Namaste.